try to solve Fibonacci series problem uh, with the Python. So let's first understand what is Fibonacci series. So basically in this series first two element is always 1, and then third element will be sum of last two element, that is 2, and next element will be sum of previous two element, which is 2 and 1. So next element will be 3, and the next element will be 5, sum of 2 and 3. So it goes so on, and like next element will be 8, sum of 5 and 3. So basically nth element will be sum of n minus 1 and n minus 2 element. So this is the series which we try to generate using Python language. So I'm using Jupyter notebook for this. So let's create a function to solve this problem. So I'm creating a function with fib name, and I will pass a number n to the function, and it will return me nth number of Fibonacci series. So let's first handle the base case. So base case will be when n less than 3, that is n2 or n1. So in that case element will be 1. As we know, first two element of the series will be 1, and if user pass less than 1 value, that is 0 or negative number, then I have to return invalid input. Yeah, because number should start from 1, because first element series will start from element 1 2 3 like this. And so we have already handled base case here. Let's return the next element which is not a base case. So we go by the formulas. Formula is like return n minus 1 plus n minus 2. So we are done. So let's test this function we just created. So first element will be 1, second element will be 1, third element will be 2, yes it is, and fourth element will be 3, and fifth element will be 5, and sixth element will be 8, seventh element will be 15. Okay, so it's working fine. We have created a method to generate nth Fibonacci series number, but it worked fine for small number. But if you try with some larger number, it takes time. Let's add time here so that we know how much time it taken to return. So it will take few minutes, and this is happening because if you look at the Fibonacci series again, so let's take the example of 8. So how it is calculating, like I pass 8 to the method, so it will return sum of 6 plus 7. We know this is the property of Fibonacci series, sum of 4 and 5. Here again sum of 5 and 6. Now here we have sum of 2 and 3. Let's go it sum of 1 1. We can say 2 is our base case. So in case of 3 it is sum of 2 and 1. So again here we have 2 base case. This is our base case, This is our same is here, like 3 and 2. So it goes on and on. So if we look that we are calculating sum of 3 here and here again, same in this sequence somewhere down below the line, and here also the same. So basically we are repeating the value we already calculated. We are doing it again and again, so that is why it is taking a lot of time in case of very large number. So what should we do now? So there is a solution to this problem, and we call it, we can optimize it using memoization. So let's see how we can do that. So basically let me copy my function from above and I am pasting it here. Let me rename it with memo. So memoization is basically a technique where we remember the result of one of the iteration which we already calculated. We save it in our memo object. So for example, here I am saving the result of my base case, that is 1, and here also instead of returning the value, I am saving it in my memo object. So it is very simple, as you can see that. And then let me turn this value, and I have to pass this memo object in recursion call. So I think we are done. So let's test this fab memo with the 40. It gives some error, so let's see what is it. So it is okay. So basically we have to rename this fib as fib memo. So let's run this again. This time it is again taking more time than I expected. Maybe we missed something. Okay, yes, we missed one important thing. So after handling base cases, we must check if n in our memo. If yes, then return memo n, right? So let me interrupt this function call, otherwise it will. Here we see it returns result immediately when I called. So as you can see, using this small simple technique called memoization, our result is highly optimized. For example, if I call this fib function and see how much time it has taken, and we already seen that it is return fib memo return immediately almost, and it is still going on and on. Let's wait for it to finish. Still not finished. I don't know how much time it will take. Okay, let's leave it. So we already seen that using memorization technique we can highly optimize our result. So that's it from this video. Thanks for watching.